Yes. Right. Yes. Right. Yes. Right. Yes. Yes. Uh, right. Okay. Now yesterday is Sunday, right? Sunday day, many problems. Right. Sometimes I love this mic. Sometimes I hate this mic. My mic becomes a enemy for me sometimes. So yesterday we could not do the class also. So today we are doing that remaining hours because covering a syllabus is not easy as you think by teaching all the points properly, right? So okay, right. So therefore it takes some time. Mm, 9 6. Uh, I think last day we discussed YouTube, and still we have to discuss. We want to discuss YouTube questions. I think I only discussed only one YouTube question. Don't worry, T and I we are doing them. Don't worry, we'll cover all the YouTube questions little by little in T and I sessions. Right, theory will speed up like this. Separately, T and I sessions we are doing YouTube questions more by giving some time you to try and discussing. Okay, but I don't reduce the number of questions. But somehow we in theory class also you know that we discuss questions. I like to discuss more questions, but some people want to cover the syllabus quickly, right? Some people don't like, some of you don't like uh, to do more questions. But I'm not in that mindset. But I want to do a class which is suitable for all of them, right? So that's why, anyways, it's a good class, ni? Right? Okay. Now, last day, where did we stop exactly? I was talking about another characteristic, ni? I was talking about a characteristic. Now, tell me, did we write a point like this? The force produced due to pressure are perpendicular to the surface at that point of application? Can someone reply? Did I explain that point? Did we write that point as a note? Can someone reply? Reply someone quickly. Did we write a point like this? Did you write a point like force produced due to pressure are perpendicular to the surface at the point of application? Did you write something like that? Reply. Yes, right. But I think when I was explaining only that problem happened. Ni? Okay. Okay. Right. Listen carefully. Now, I think I told you last day we know that pressure is a scale, right? That means pressure does not have any direction. And I told you pressure means we defined as right. Now listen. Now listen. Okay. Right. Yes. This story. Now just consider a container. And this container is filled with a liquid. Filled with a liquid. Okay, careful listen story. All these points important when you do a question. Normally, hydrostatics, they can ask very beautiful questions. Very practical questions they can ask from hydrostatics. Now, just consider a point in the liquid. This point is point capital E. Then if I ask you, uh, are there any pressure at point A? Yes, there is a pressure. Pressure produces at A due to the weight of the liquid particles above point A and also that atmospheric pull. We learned that idea. If I ask you to find the magnitude of pressure at point A, you can say that H rho G plus phi. We learned that point. But if I ask you, okay, at point A, what is the direction of pressure acting? What is the direction of pressure at point A? You guys can't tell a certain direction. Remember, when you consider a point in the liquid, pressure acts in all the directions. The pressure acts in all the directions. At that point, pressure acts in all the directions. Okay. So therefore, draw this diagram. Mark a point capital A, and draw this diagram. Pressure is acting in all the directions. That is first point. Okay. So quickly draw this diagram, and also remember, if you consider a point, this point is in the liquid. When you consider a point, touches the container, touches the solid. I take point capital B. Point capital B. If I enlarge this region, this is your vertical wall of the container, and this is the liquid. Your point B touches the container. Then remember, then what will happen? There is a pressure at B. If I ask you what is the pressure at B, H rho G plus phi. But remember, due to the liquid pressure at point B, this liquid creates a force at point B towards the container. Because we know pressure means force over area. Pressure means force over area. When you subject force, force means pressure into area. So understand, due to the liquid pressure at point B, there is a pressure force at point B towards B. Right? Also remember, the pressure force always perpendicular to the container. The pressure force always perpendicular to the contact surface. So then if you mark the pressure force at point B, capital F, FB, then you should understand the liquid in contact with the container. All the points in the container undergoes kind of pressure force. Am I correct? Right? You know pressure force is proportional to the pressure. We know that from top to bottom, what will happen with the pressure? From top to the bottom, pressure increases. That means what can you say about the pressure force? Also increases from top to the bottom. So if I consider this point as point C, this point is point D. If I ask you to mark the pressure force at point C and point D, we know pressure force always perpendicular to the contact surface towards the contact surface. We know point C, pressure force is smaller. point D pressure force is bit larger. Point B pressure force is largest. Do you understand? So then, if you mark the pressure force acting on the container filled with a liquid, then this is how you have to mark the pressure forces acting on the container, right? Then you should mark something like this. Pressure force perpendicular to the container. Pressure force this side. Then what can you say about the pressure force acting at the bottom of the container? When you consider any point, if I consider bottom, when you consider any point on the bottom, what can you say about the total pressure at any point on the bottom? Since when you are considering the bottom surface of the container, all the points are at the same horizontal level, right? In the same liquid, then you know pressure forces acting at any point on the bottom is same. If you mark the pressure forces perpendicular to the container towards the container. So write these diagrams. Do you understand? Hands up, how many of you understood the story? Hands up. Pressure force. Due to the pressure, there is a pressure force. Hands up. This story, do you understand? Hands up. If you understood, hands up. Quickly. This diagram quickly. So nicely draw evenly. Now see, this is not look like an even diagram. Arrows, when you draw it, evenly draw it. And this is the bottom. Now you know pressure is maximum at the bottom. Why pressure force is maximum at the bottom? Pressure is maximum at the bottom. Then the corresponding pressure force at the bottom is maximum. So therefore, write those things. This idea. So then I think this is the point number 4th to 5th one. Can you remember now? We were talking about important points in hydrostatics. I think this is point number 4 or 5. Reply someone. Point number 5. Point number 5. Okay, then next point. I think already I gave the point, right? Already I gave the points. Pressure force perpendicular to the container. At a point in the liquid, pressure acts in all the directions. I think we wrote the point. Is there anything to write or just draw? Only just draw it. If you want to write something, write down. You just write down pressure acting at the bottom. Right? When we go deeper, pressure force is maximum. When you go deeper, pressure force is maximum. With your words, you write down. Don't expect all the points from me. If you feel something important, you write, because note should be prepared by yourself, right? If you feel something is important, write down. I give the general note. If you think this is important, if you think that you will forget tomorrow when you look at the note, if you think that you forget, okay, what I taught yesterday, then write down now. This is the idea. Now I am explaining the ideas. Right. Next point, write down. Next points are easy. I think next point write down. I think if this is the 4th point, next one is 5th point. If this is the 5th point, next point is 6th point, write down 6th point. When a gas in the container, gas pressure at any point in the container is same. Gas pressure at any point in the container is same. Gas pressure at any point in the container is same. Now just consider, now there is a container, a closed container, because now there is a closed container. A gas is filled inside the container. Because now when the container is opened, is it possible to store a gas? Not possible, right? This is a closed container. Now, kind of gas is inserted in the container. That can be oxygen, nitrogen, or helium, any gas. If not, it can be normal air. Right? If I draw the gas particles, Now we know that we have to assume all these gas particles are evenly distributed in the container. Remember, if it is a liquid filled in the container, point to point, depth to depth, we learned hydrostatic pressure is different. When we go more deeper, hydrostatic pressure increases. But if it is a gas filled in the container, remember, no matter whatever the point in the gas container, it can be point capital A, point capital B, point capital C, point capital D, remember, pressure at A, B, C, D are same. If it is a gas in the container, pressure at any point in the container is same. But if it is liquid, you know, when we go more deeper, pressure is increasing. In the same liquid level, pressure same. So write down to this diagram, pressure at point A equals pressure at point B, pressure at point C, pressure at point D. Now, all these points are important when you do a question. Quickly. Then next point. Next one, write down. Next one, write down. Next point. Nothing to understand, very easy idea. Next question, next point, write down. When there is a liquid and a gas in contact with each other. Next point. When there is a liquid and gas in contact with each other. When there is a liquid and gas in contact with each other, comma, red color pen, the pressure at the surface, the pressure at the free surface of that liquid, the pressure at the free surface of that liquid, the pressure at the free surface of that liquid equals to gas pressure, equals to gas pressure, equals to gas pressure. Now next story, something like this. Again, consider a closed container. A liquid is filled initially, then gas is filled. So this closed container contains liquid as well as a gas. This container contains liquid as well as gas. So liquid can be water or any liquid. Gas also can be any gas, oxygen, hydrogen, whatever. It is liquid. Gas. This one is gas. So I represent the red color dots. Gas particles, I represent in the red color dots. Right? Sometimes you can't see this is red gas. Remember, when you consider, now we know that in a liquid, in the same horizontal level, pressure same. But when you consider any point on the free liquid surface, point capital A, point capital B, point capital C. When you consider any point at the free liquid surface, pressure always equals to gas pressure. Right? If you consider gas pressure, I told you in a gas, when you consider any point in the gas, pressure is same. This story. I say pressure of the gas is, let's say, PG. Remember, when you consider any point at the free surface of the liquid, pressure is equal to gas pressure. So remember, PA, PB, PC must be equal to PG. Right? The point in contact with the gas always obtains gas pressure. PG. Write down this one. These are not difficult points, can understand. Then next point. Next point, write down. Next point. Now draw all these things up. Draw now when you always maintain a theory, perfect theory note. Because in the end of your exam, when you close to the exam, no one is there with you other than your notes. Even if you are doing in case, if you are doing second shy, this note is very helpful, very important. So therefore maintain a best knot. Okay, right. Next point. Next point, write down. I think this point, next point, write down. When there are many, when there are many immiscible liquids, when there are many immiscible liquids, when there are many immiscible liquids with different densities containing in a vessel, containing in a vessel, comma, then the total pressure at the bottom, total pressure at the bottom, then the total pressure at the bottom of the container, total pressure at the bottom of the container can be found as below, can be found as below, can be found as below. Right. Now, do you know the meaning of miscible, immiscible? Now, we know miscible means when you consider two liquids, they mix with each other. Once they are mixed, you can't identify separately the liquids you mixed. Example is when you add water to the milk, once you mix them together, they mix very well. Then by looking at the mixture, can you identify this is water and this is water? No. So now there are liquids, they are miscible. They mix very well with each other. What is immiscible? No matter how much you try to two different liquids, no matter how much you try to mix two liquids together, they don't like to mix with each other. They always like to separate. They always like to separate. For an example, water and coconut oil. So when you try to mix water and coconut oil, always coconut oil wants to separate with water. You can clearly identify. Once you mixed, you can identify since they are separated. This is water, this is coconut oil. That is the meaning of immiscible. Now consider in the container, three immiscible liquids are poured, densities are different. Normally remember now, let's say now there are three different liquids, water, coconut oil and something else. Then we know density of water is larger, right? There are three, just consider there are three different liquids, liquid A, liquid B, liquid C. Liquid A has the larger density. Liquid C has the small density. Then we know that always remember the larger density liquid will be at the bottom. The lower density of the liquid will be always in the top, right? Now I'm pouring three different liquids. Initially, I pour the larger density liquid. I represent the larger density liquid in black color, right? You also draw with me. Draw with me. There are three different liquids. This is in black color. So then this liquid is liquid capital A, right? Density of this liquid is, let's say, rho capital A. The liquid height, let's consider simple HA. Liquid height is HA. Liquid height is HA. Then you add the lesser density liquid B. So when you consider liquid A and liquid B has a lower density. Liquid B I mark in blue color. Liquid B is in blue color. Then density of liquid B is, let's say, rho B. Liquid B. The height of the liquid B is H simple B. H capital B. Then the lower density liquid we are pouring into this container, that is liquid C. That is liquid C. This is liquid C. So you also draw with me. Liquid C, the height is, we know that HC, density is rho C. Then we know atmospheric pressure acting on liquid C. right? Because this container is open to the atmosphere, therefore atmospheric pressure is acting. Okay, I forgot to tell one important point. Somewhere is written important, somewhere is written important. When the container is closed, remember, we don't consider the atmospheric pressure. When the container is open to the surrounding only, we consider the atmospheric pressure. Remember, write down an important point, red color pen. When the container is closed, comma, then the atmospheric pressure is neglected. When the container is closed, then the atmospheric pressure is neglected. Next point, red color pen. Atmospheric pressure is considered. Atmospheric pressure is considered. Atmospheric pressure is considered when the container is opened to the atmosphere. Atmospheric pressure is considered when the container is open to the atmosphere. So atmospheric pressure is 5. Now, I will take few points. This point is, I'll take it as point capital X. This point is point capital Y. This point is point capital Z. I take this point as point capital K, point capital K. If I ask you, what is the pressure? What is the total pressure at point capital X? When you consider point capital S, the above point capital X, there is only atmosphere. Then if you are at point capital X, you feel only the atmospheric pressure. Am I correct? Because you don't feel the pressure below you, right? Just think now, there are 10 students. One student lies on top of other student. Right? The one student lies on the other student. Now 1, 2, 3 on top of other. There are 10 students light on top of each other. Right? Let's say now the top one feels any weight of below 9. No, right? The one who is laying on the top, he doesn't feel any of their weights. But the second one, it is 1, 2, 3, 4, 5. Do you think there are 5 people like they are hugging or something? They are doing something. I don't know what they are doing. Okay. Now just think. Do you think this top guy feel any weight of below 4? No. But the second guy is feeling this one's weight. Third guy is feeling these 2 guys' weight. Fourth one is feeling these 3 guys' weight. The last one is feeling all 4 guys' weight. So therefore, remember, when you consider point capital X, it only feels the pressure of atmosphere. So we can write down pressure at point X. That means Px means only the 5. 10 to the power 5 pascals if you want. I take it as equation 1. Right? Now in question, you want to do this. When you consider point capital Y, what is the pressure? Total pressure at point capital Y? Above point capital Y, there is only liquid C and the atmospheric pressure. So I can write down pressure at point capital Y means we can write down how? How do you find the hydrostatic pressure of liquid C? H rho G. H rho G equation, Hc, height, density of the liquid is rho C, gravitational acceleration is G plus phi. Okay. This is one approach. If not, what you can write down? If not, you can write down, since the phi equals Px, since phi equals Px, you can write down Hc rho Cg plus Px. If you want, you can write down Py as Hc rho Cg plus. If you want. If you want, you can write down phi means we know that is from equation 1 Px. The different approaches, I think they are. Then what can you say about the pressure at point capital Z? Pressure at point capital Z means we can write down now above point capital Z, there are 2 different liquids. Liquid B also above point capital Z, liquid C also above point capital Z. Capital Z feels hydrostatic pressure of B and hydrostatic pressure of liquid C plus atmospheric pressure. So then remember PZ means remember hydrostatic pressure of liquid B means HB rho Bg plus hydrostatic pressure of liquid C means Hc rho Cg, not rho C, plus phi. Right? Now one can do something like this. One can write down, look here. Hc rho Cg plus phi means Hc rho Cg plus phi means what? From equation, I take this as equation 2. Hc rho Cg plus phi means from equation 2, that is Py. Am I correct? So one can write down PZ means HB rho BG plus HC rho CG plus 5 means from equation 2 PY. Write on these things. You want to finish the syllabus quickly. Teaching everything properly and completing is not easy as you think. From equation 2. From equation 2. Then likewise find the pressure at point K. Find the pressure at point K. When we find the pressure at point K, we can write down PK. PK means we know point K fills hydrostatic pressures of these three liquids. Hydrostatic pressure of liquid A is HA rho Vg plus hydrostatic pressure of liquid B is HP rho Bg. Liquid C means what? HC rho Cg plus 5. Hands up to now everything is very clear. Hands up. If you understand everything so far, everything is very clear. Hands up. Raise your hands. Everything is very clear. Hands up. Very clear. Right. Then what you do? Write down. Now, if you want, you can write down HB rho BG plus HC rho CG plus 5 means this one is what? This one is what? PZ. So you can write down PK means HC rho AG plus PZ. Likewise, write down the story. So understand, right? When there are many immiscible liquids, so you know how to find the corresponding pressures. That is the idea. Now, still you can't do any questions, but little by little we are giving the theory. I am giving the idea. You absorb it. You absorb it and you develop your mind of thinking. Because in your O levels, you never learned about liquids, right? You learned about pressure. You didn't learn what is hydrostatic pressure in depth. Right now I am showing the picture. Try to absorb. Try to carefully look at the picture and try to identify the important things that you see in the picture. So I am explaining little by little. I am giving the idea. You go in deep and you feel that. Right? When I say a liquid, in your mind, you should imagine, there's a liquid. So when I tell liquid pressure at point A means naturally you should feel there's a liquid, there is a point inside the liquid. You should have kind of imagination power. Right? Imagine. If I tell vehicle is coming with a velocity of 100, so you should imagine there is a vehicle. Think about the speed, how it's coming. Feel. A vehicle is coming with 100 means you know that it's not coming like this. When you imagine that scenario, you should feel, right? You should feel like this. Vehicle coming with 100 ms per second, very huge speed, like this. Likewise, imagine. Right? Okay. That story also done. Okay, now, okay, that is also done. Then important points are done. I think that's all important points, right? Important points, that's all. Now we'll talk about this liquid manometer and liquid barometer. Now we want to measure pressure. Now you know what is pressure. Then we should measure the pressure. Then we should need some devices to measure the pressure. Now you might have seen some pressure gauges to measure the pressure. But those days, they have used two different instruments to measure the pressure of a liquid. One is we call as liquid manometer. Other one is we call as liquid barometer. They have tested liquid manometer, barometer knowledge in exams as MCQs. Put your main topic, liquid manometer. Liquid manometer. Liquid manometer. So don't keep any doubts up to the theory that we learned. Don't keep any doubts. Right? If you have doubts, you can ask. You know, I am normally very friendly. Right? So you can ask any doubt. Now you are adults. You guys matured, right? Now 27 batch also coming. That means you have 1 year experience. I think we have started class around before 8 months. I think it's 8 months. No, June, July, August, September, October, November, December, January, February. It's around 9 months. Almost 1 year. You learned physics almost 1 year. But you can't learn physics to this level in any way. I'm sure. I don't lie normally. I lie, but normally I know that because as a teacher I compare. I have to compare. I check how others teaching. And if something is good in one teacher, I always try to get that, because day by day we want to develop. That's it, right? Some people can say I'm copying, but always I see others, right? I see others and I learn from them. Uh, right. Uh, yes, right, ne? Right. So I see others, I learn from them. So then I compare all the teachers, how they teach. So now teaching physics in deep, I think I now the way I teach, some of you might like, some of you might don't like the way I teach, right? But I assume that all of you here come to my class because that the way I teach, you can understand, right? So then when I consider the way I teach, I copied entirely from my physics teacher, right? I learned physics from two different teachers. Basically, they are single medium teachers, but the leading single medium teachers, right? So but still I know that I can't teach like my teacher. So the way he teaches physics is really amazing, but most of you don't like the way he teaches. But I personally like the way he taught physics to me. I went for a mass class. There are around 2000 students in one class, one huge hall. There are around 2000 students. So actually normally when I go to the time, when I go to the class, I go early. Generally, I go I think half an hour before the class time. Even I go like that, some I have to sit mostly behind the class. All the time I try to sit in the middle or in front, but sometimes there is no seat. There was no seat, right? So the way sometimes my accent, everything very similar to the teacher, but still I can't be like him. But he's my role model in this teaching. When it comes to English medium classes, I think I didn't see any teacher teaches to this that level. Even no teacher can teach to my level also. I just compared. So therefore, what I'm saying is I'm comparing. I'm comparing, and if I see a teacher is teaching really good, I get those things and I add to myself. I add to myself. Day by day, I'm developing. Just take 2 years before my teaching recording, and now the way I teaching. You might have observed there is a significant difference in my teaching. So that happens. That's like that. I also say that always try to absorb when you see something is good in someone. Always try to get absorb it. Always learn from people. That is not always copying. You can learn many from people. You can learn many from good people as well as bad people. You can learn. So therefore learn. Okay. Right. Liquid manometer. Storage liquid manometer. Now we are finishing the theory. We can start upthrust. The most important section in hydrostatic is upthrust. Liquid manometer. Now draw this diagram. Write down. Liquid manometer is used to measure the pressure of gases. Write down. Liquid manometer is used to measure the pressure of gases. Highlight gases. And draw this diagram with me. Draw this diagram with me. This diagram. So a spherical hollow sphere is connected to a U-tube. That is the basic idea behind the liquid manometer. Right. Now, now forget about this side. Forget about this side. And this side is you are very familiar. It looks like a YouTube, and there is a liquid inside the YouTube. There's a liquid, right? There is only one liquid. So then let's say now if there is now forget about this side. Now cut this side. Cut this tube from this end, and you separate this YouTube, and just fill liquid. Once you fill the liquid, this is how the liquid looks like in both arms, because we know that the liquid fills in both the arms up to same liquid height, up to same liquid height. That idea you know already. Now what would happen now if I ask you, I take this point as point capital E. Carefully listen to this story. Forget about this side. Now I take this point as point capital E. This point is point capital B. Okay. Then we know initially we know what can you say about the point capital A and point capital B's pressure? Point capital A and point capital B both are open to atmosphere. Then point capital A and point capital B feel the atmospheric pressure. Am I correct? But what will happen? Now just think there is a gas fill in this container and this is closed. There is a kind of tap or something. There is kind of what lid or something. There is a gas fill in this container and this container is closed. Now you want to find the pressure of the gas, because we know liquid manometers are used to find the pressure of the gas. So you have a U-tube. There is a liquid in the U-tube. We know that pressure at point A and point B are same. Therefore, both the arms liquid has filled up to same liquid height. I want to measure the pressure of this gas in this container. So then what are you going to do? You are going to merge, you are going to connect this end with this U-tube. After connected, what you see when you keep on observing the liquid height in the U-tube, you observe because of this gas pressure. Because of the gas pressure, this gas is passing through this U-tube, gas is passing through this tube, and this gas is pressing liquid at point A. Then what will happen? Once the gas pushing the liquid in the left side arm, now what happens? Liquid level changes. Earlier this was the liquid level. Now what will happen? Now liquid in left side arm goes down. Liquid level in right side arm goes up. The reduced liquid volume equals to increased liquid volume. That story I taught you. Now the liquid level will be, let's say somewhere here. Now the liquid level is somewhere here. Carefully listen the story. Carefully listen. Then at the liquid level at B increased. Now the liquid level is somewhere here. Right? Carefully listen the story, huh? Okay. Now up to here there is gas. I say now I want to find the pressure of the gas. That's why I connected this container includes gas with the U-tube. I say pressure of the gas as PG. Pressure of the gas is PG. I'll ask a question. What is the pressure at point capital C? Point capital C is exactly the interface between liquid and gas. Quickly reply, what is the pressure at point capital C? Reply quickly. Put a reply. What should be the pressure at point C? From the theory what I taught you, you can answer. Reply everyone quickly. Reply, what should be the pressure at point C? Reply. Reply. What is the answer? You want to reply to Sir account. Huh? Don't reply to Suleiman Namas. Sir account. Reply everyone. I'm expecting answers. Everyone reply. Now this gas country is connected to YouTube at point C. What is the pressure? I need answers. I need answers because I'm teaching that level. Reply everyone. Only two replied. Only two replied. Reply everyone. You are good boys and good girls. No. Reply everyone quickly. I didn't get any reply from Lakshya, Fatima, Vibashi, then our Amaya, Ikram bro. Reply bro. Are you there? Are you sleeping? I didn't get a reply still. What should be the pressure at point C? What is the pressure at point C? No replies. So remember, I told you if it is a gas, any point on the gas, pressure is same. So the gas pressure at any point up to here, same pressure, that is Pg. And I told you another point. Now, when there is a liquid and gas, when you consider free surface of the liquid, pressure at the free surface of the liquid equals to pressure of the gas. Then we know that pressure at point C equals to pressure of the gas Pg. So you know that idea, pressure at point C equals to pressure of the gas Pg. Equation 1. What's your target? Your target is somehow to find the pressure of the gas. And then the next story, let's say suppose you know this height. Let's say you know this height. This height is they have given, you can measure this height using meter ruler. We can measure the height. And we know this end of the YouTube is opened. Then there is atmospheric pressure also acting in the right side arm. Because this side is closed. So because this side is closed, gas pressure is acting in the left side arm. PC pressure means pressure of the gas. The right side atmospheric pressure is acting while this right side arm is open to the atmosphere. Now just consider in the same liquid we learned, in the same liquid, same horizontal level, pressure should be same. Then what can you say about when you consider point C and point D, they are in the same horizontal level. Since we can write down, since point C and point D are at same horizontal level and same liquid, what can we write? We can write down pressure at point C should be equal to pressure at point D. Am I correct? Pressure at point C equal to pressure at point D. This is equation 2. Can you find pressure at point D? Let's say density of this liquid is rho. They have given density of the liquid is rho. Write down rho means density of the liquid. What is that? Can you tell me pressure at total pressure at point D in terms of rho? We know point D feels hydrostatic pressure of this liquid column above point D plus atmospheric pressure. So we can write down pressure at point D means we can write down H rho G plus phi. Equation 3. So finally what you can do from equation 1, PC means PG. From equation 3, PD means H rho G plus phi. Therefore, you can write down from equation 1, 2, 3, you can write down. Pressure of the gas means, remember, PG means H rho G plus phi. This is how we find the pressure of the gas. Right? That story. Hands up. Understood, hands up. Understood, hands up online. Understood, hands up. Understood, hands up. Right, okay. Then finish writing, raise your hands. Once you finish drawing, raise your hands. Once you finish drawing, raise your hands. So we'll write sample question also. Sample question, then we'll talk about uh, liquid parameter also. If you finish writing, raise your hands. Give me 1 second, I'll be back. Huh? Right, done. Right, done. Okay. Now, this is the idea. Now, think there is a now when you consider this YouTube, one side there is gas pressure, other side there is atmospheric pressure. Now, just think initially liquid levels in the YouTube was in the same horizontal level, A and B. What happens now? Atmospheric pressure also pulling the liquid right side column liquid arm. Ne? Atmosphere pressure also pulls the right side liquid column, and gas also pulls the left side of the liquid column. Just think when the just think I'll ask a question. Now from this equation also you can tell me which pressure is larger. Raise your hands. How many of you say now in this now idea is very simple. There's a YouTube liquids are at right and left side arms. Right, left side according to you, your hand is left side. Left side gas pressure is pulling the liquid column. Right side atmospheric pressure is pulling the liquid column. My question is, raise your hands. How many of you say in this scenario gas pressure is larger than atmospheric pressure? And how many of you say in this scenario, considering the pull, considering the liquid level deviation, hands up? How many of you say gas pressure is larger than the atmospheric pressure? Hands up. Gas pressure is larger than the atmospheric pressure. Hands up. Because of the gas pressure is larger only, what happens now? Initially liquid level was in the same level, both the arms liquid level was same, but due to the gas pressure is high, comparing with the atmosphere pressure, your liquid goes like this. But what could happen, suppose if the atmospheric pressure is larger than the gas pressure? If the atmospheric pressure is larger than the gas pressure, then atmospheric pull is high, then the liquid column in the right side goes down, liquid column in the left side goes up. Am I correct? So this is case 1. Put this as case 1 and you draw this diagram. And what you do, again put case 2. Again put case 2. Now case 2, write down gas pressure is lesser than the atmospheric pressure. In case 1, write down, you have drawn this diagram. So in this diagram, write down case 1. Case 1, gas pressure is larger than atmospheric pressure. Then this is the diagram, how it looks like. In case 2, what you do, right, again to this diagram, case 2, what you do, gas pressure is less than the atmospheric pressure. Case 2, write down, gas pressure is less than the atmospheric pressure. Right, then what will happen? If I draw quickly, if I draw roughly, in that case, now gas pressure is less than the atmospheric pressure. Then what will happen? Earlier liquid was in the same level. Due to the high atmospheric pressure, liquid in the right side arm goes down, liquid in the left side arm goes up. Okay, this is your liquid. This is your liquid. This diagram. And this point is named as point C, point D. This point is point C. This point is point D. Point C and point D are the same horizontal level. And they have given this height is simple h. Density of the liquid is rho. Gas pressure is Pg. Gas pressure Pg. Right. Let's take this point as point capital. Let's say this point is point capital. Let's say this point is point capital. Okay, point capital A. Then you know that first equation is, we know what is the pressure at point A equals to gas pressure Pg. We know pressure at point A means gas pressure Pg. Equation 1. Right. And you know that since point C and point D at the same horizontal level in the same liquid, we know pressure at point C and point D are equal. Pressure at point C and point D are equal. I don't explain deeper, you know. You want to write the story, right? Since point C and point D at the same horizontal level and in the same liquid, pressure at point C and pressure at point D are equal. Equation 2. The last one, can you find the pressure at point, can you tell me the pressure at point D? Pressure at point D means, atmospheric pressure 5. Am I correct? Because at point D only feels the atmospheric pressure. Pressure at point D means atmospheric pressure, equation 3. Again, find pressure at point C. Pressure at point C means what? Pressure at point C means, you can write down like this. Pressure at point C means point C feels this liquid column hydrostatic pressure and gas pressure. Because there is gas pressure, pressure at point C feels this liquid column pressure plus gas pressure. Then I can write down H rho G plus gas pressure is Pg. So what you can do here from equation, what you can do here, see here what you can do from equation 2, Pc means Pd. H rho G plus Pg. From equation 3, Pd means 5. Pd means 5. H rho G plus Pg. And now you can write down pressure at point G, gas pressure means what? Atmospheric pressure minus H rho G. See, they have asked these things in the exam questions. You will learn when we do past papers, then we can catch all these things. Don't you worry. I will do everything properly. Don't you worry. Now, this is the story of liquid manometer. Then, basic liquid manometer means a U-tube. Based on the liquid height deviation, we can measure the height difference in the liquid levels. Then we can find the gas pressure. When the gas pressure is higher than the atmospheric pressure, this is the diagram. When the gas pressure is less than the atmospheric pressure, is the diagram. That is the idea. Okay. I hope you understand overall idea. Now put your main topic. Now today we are not doing questions, we are doing the theory. Okay. Until 11 o'clock, I am doing the theory. Now main topic. Now liquid manometer used to measure the gas pressure. You understand? Then put your then what you do? Then put your main topic, liquid barometer. Next topic is liquid barometer. Liquid barometer. Then we can talk about upthrust. Liquid barometer. Write down. Now, liquid manometer is used to measure the gas pressure. But remember, generally, liquid barometers are used to measure the atmospheric pressure. Because I will tell you one point. If I ask you generally what is the atmospheric pressure, you tell that atmospheric pressure will be 10 to the power 5 pascals. Right? If I ask you a question, raise your hands, how many of you say in Sri Lanka? How many of you say when you consider any location in Sri Lanka, atmospheric pressure is same as when you consider Sri Lanka country, when you consider different locations, Nuvarelia, then near to the sea, Colombo, Negombo. Raise your hands, how many of you say when you consider Jaffna, any place in the Sri Lanka country, how many of you say atmospheric pressure is same answer? Atmospheric pressure is different answer. Place to place, atmospheric pressure should be different answer. Remember, that is different. Generally understand when we go in the middle of the country, we know when we go to the hillside, from sea level to the hillside, remember, right? This is your sea level. This is sea. When you go from the sea level to the hillside, remember, atmospheric pressure decreases. Okay. So we will learn this in unit for heat also. When we go from sea level to the hillside, atmospheric pressure decreases. Because when we go more and more up from the ground, there's a reason behind that. I don't want to tell that reason. Just keep in your mind. Place to place, based on the altitude, pressure decreases. That is the idea. Okay, not always above 5 pascals. But generally, if they specifically not mentioned, always we consider atmospheric pressure as above 5 pascal. Okay, that is the idea. So now normally liquid barometers used to measure the atmospheric pressure. So now you understood place to place atmospheric pressure is different. So therefore we need an instrument to measure the atmospheric pressure, that is liquid barometer. Write down a point, write down. Liquid barometers are used to measure atmospheric pressure. Highlight atmospheric pressure. Okay. I will draw the diagram of liquid barometer. It's very simple. By the name liquid barometer, there is a liquid in this instrument. That liquid is mercury. The liquid that we use to manufacture liquid barometer is mercury. Right? And mercury is filled to a container. And again, another set of mercury is filled to a capillary tube. The combined setup is liquid barometer. Now draw this diagram with me. Liquid barometer. Now, this diagram draw with me. Very simple diagram. Right. So this is a capillary tube. And this is a container. And mercury is filled. Don't worry, I will explain in deeper. First of all, do this diagram. Now, generally, now, you can you can make a liquid barometer. If you are planning to make a liquid barometer, first of all, you should select a capillary tube. Capillary tube means generally very thin tube of length 1 meter, right? The length of this tube should be around 1 meter, right? And then, first of all, you should take the capillary tube and you should fill that capillary tube completely with the mercury. You should fill the capillary tube completely with the mercury. And also, you want to take a container. That container also, no, not completely filled with the mercury, but up to some level, you should fill that container also with the mercury, right? So generally, length of this tube is around 1 meter, 100 centimeters. After you filled the capillary tube and the container, what you should do is you should you should put this capillary tube inside the container like this. You should turn like this quickly. Huh? Then what you notice, actually, initially you completely fill the capillary tube. But once you turn the capillary tube and once you put into this container, you see some amount of mercury in the capillary tube has reduced. Generally, remember, we say that in this region where you can't see any mercury, in this empty region we are calling as vacuum. This region is vacuumed. Because think, once you completely fill the capillary tube, this region was filled full of mercury. Then what happens? Once you turn and once you place like this, now you can't see any mercury in this region. This region is empty. Is it possible to have any gas in the region? Not possible, right? Because earlier this region was occupied by the mercury. Now this is empty. Therefore, remember, this region is vacuum. Vacuum means there isn't any gases or molecules. So this region is vacuum. Okay. What happens? You can see kind of reduction in the mercury column in the capillary tube. Okay. So I say now when you measure this height, this height is, let's say, simple h. This height is simple h. And I'll take few points on the free liquid surface of the mercury in the container. I'm going to take few points in the mercury liquid in the container. This point is point capital A. This point is point capital B. Raise your hands. How many of you say the pressure at point capital A should be equal to pressure at point capital B? Hands up. Raise your hands. How many of you say the pressure at point capital A should be equal to pressure at point capital B? Raise your hands. Anyone? Anyone? They should be equal, right? Because why? Because point capital A and point capital B both are in the same horizontal level. Point capital A and point capital B both are in the same liquid. Then the requirement is both of them should have same pressure. Am I correct? Their pressure should be same, right? Hands up who understand pressure at point capital A and pressure at point capital B are same. Hands up. If you understand, hands up, please support me. Because I'm assuming you guys understand. Right? Right? We'll do questions in the class next day, okay? Now they are same because same liquid, mercury in the same horizontal level, their pressure must be same. Then you know that this container is open to the atmosphere, then point capital A, if not free mercury liquid surface, feels the atmospheric pressure. Atmospheric pressure is 5. Atmospheric pressure is 5. If I ask you, what is the pressure at point capital A? Pressure at point capital B, pressure at point capital A equals to atmospheric pressure 5. Am I correct? Because point capital A only feels the atmospheric pull. Pressure at point capital A means only the atmospheric pressure 5. So you know that P capital A equals to 5. Equation 1. Right. And also we know that pressure at point capital B, if I ask you, Pressure at point capital B equals to how much? Uh, Point capital B feels the hydrostatic pressure of this mercury liquid column. Height is h. Density of the mercury, take it as rho. Gravitational acceleration is g. Then point capital B feels only the hydrostatic pressure of mercury column. Above mercury, there is only gas, right? There's a vacuum only. Vacuum means no gas. So therefore, point capital B feels only the hydrostatic pressure of mercury column H rho G, equation 2. And we know that since point capital A and point capital B, since point capital A, point capital B at same liquid mercury, same horizontal level, we can write down what? We can write down PA must be equal to PB. Am I correct? Their pressure same. PA must be equal to PB. PA means we know phi. PB means we know H rho G. Why we use liquid barometer? Liquid barometer is used to measure the atmospheric pressure. Then understand, phi means, remember, phi means H rho G. If you can measure this height using a meter ruler, density of mercury is generally, remember, somewhere else write down, density of mercury is generally 13,600 kilogram per meter cube. Normally, mercury means high density liquid than the water. Water density is 1000. Mercury density is 13,600. Very high density liquid. So then remember, if you want to find the atmospheric pressure, so you should bring, what happens now? Now we understood atmospheric pressure always equal to H rho G. If you can measure this height from free liquid surface to the meniscus in the tube, free liquid surface to meniscus in the tube, right? Now please write down somewhere else, write down H means, write down H means the vertical height from the, H means write down, H means write down first. I'll give some time to write also, don't worry. H means write down the vertical height from the free liquid surface in the container to the free liquid surface in the container to the free liquid surface in the container to the liquid meniscus. Liquid meniscus in the capillary tube. Liquid meniscus in the capillary tube. Liquid meniscus in the capillary tube. Right? I'll ask a question. Now I told you when you go from sea level to the higher altitudes, sea level to the hillside, I told you pressure decreases. Now reply my question. Raise your hands. How many of you see? Now let's say now what are you doing? Now you are taking this setup and you are walking. Now you are going for a hike. You are going for a hike, very huge mountain. It can be Adara Kandaro, Knuckleso, whatever the mountain. Now you are carrying this liquid barometer. Raise your hands more and more when you climb the hill. Raise your hands. How many of you say this H height of the mercury column in the capillary tube increases and so. Now you are climbing more and more in the hill. Hands, how many of you say, now you are carrying this liquid barometer. How many of you say when you climb more and more in the mountain, how many of you say H, this height increases and up, increases and up, decreases and up, decreases and up, decreases and up. It's decreasing, right? Because I told you when you climb more and more and more, pressure decreases. Pressure means atmospheric pressure decreases. If your atmospheric pressure decreases, corresponding H also decreases. Am I correct? When the atmospheric pressure decreases, corresponding height also decreases. Very simple story, right? Is it difficult? Nothing. Now take and quickly write these things. Write the story. Once you finish writing, raise your hands. Huh? Once you finish writing, raise your hands. 10:30. Once you finish writing, raise your hands. We'll take a small break. We'll take a small break. We'll take around 10-minute break. Come at 10:30.